We'll first take a few resistors, take them out of their reel. I'm just taking commonly used resistors which I have a lot more than I usually need. And this is the soldering side of the PCB. As you can see, it's tinned pads are available on this side, and this is called the component side. Alright, when we do PCB design, this will be the top layer and this will be the bottom copper. Alright, so first what we need to do is we need to bend these resistors. We can do it by hand or using a nose plier. If you want to do it by hand, we just need to bend them. Alright, and form like this. The holes on this PCB are 1/10 of an inch apart, which is 2.54 mm. So when we place a resistor, usually it takes about 0.4 mm or 0.4 inches or 10.16 mm. So if you see here, from one pad to the other, it's about 1, 2, 3, 4 spaces. So that's 2.54 into 4, which is 10.16 mm, or it's 0.1, 0.2, 0.3, 0.4 inches. Alright. So this is the dimension that we will need. So we'll take a resistor, we will insert it from one end and bend it a little so it doesn't fall. Even now you will see that it stays in place. It doesn't go further away from the board. Alright. So I'm going to do this for about 10 or 15 resistors here, and then we'll continue from there. Once we have inserted the resistors in the general purpose board, we just need to place it on a flat surface and bend the leads so that they don't fall down, as we have to solder on this top side. So if you see here, the resistors are close to the PCB, alright, flush against the PCB itself. So we're going to place it on the floor, on the table, and then we are going to start soldering one side at least so that it stays in place. There is no one particular order in which you have to solder these. I could solder one end of the resistors as a matter of convenience, and I could solder the rest, or I could solder one resistor at a time. So for soldering, we're going to use lead. The idea is to melt the lead on the tip here so that the pad and the lead of the resistor are soldered together. So we need to first make sure that the soldering iron is hot enough. I'm just going to test it by melting a little lead and seeing if that's the case. I can see that it is hot enough. So I'm just going to heat the lead a little, and I'm going to melt the iron. I'm going to melt the lead on the lead itself. As a matter of convenience, I'm just soldering one tip of the resistor, each of these resistors, so that they'll be in place first of all. I am soldering a few leads poorly on purpose, so I can show you the difference between a poor solder and a good solder. Even if you poorly solder while you do it the first time round, we can fix this after we have completed soldering. Now I have soldered one end of the one lead of the resistor, each resistor. This is how the resistors have stuck in place while I soldered them, because we bent it already. Alright, now we will solder the other half also. Alright, so I'm just going to turn it around. I'm going to solder the other half. It's advisable to take it out a little more, the lead a little more, so that it's easier to maneuver it between these leads. Again, I am doing poor soldering on some of these leads on purpose, so I could show you what a poor solder looks like, what a good solder looks like, so you can identify it for yourself if you have done a good job. So once we have soldered all the pins, this is how the resistor array is going to look like. Right. Some of these resistors are little raised. For example, this one, if you see, it's a little raised out of its place. This is snugly fit in place. So this is going to happen little. We are going to reposition these resistors after we remove the leads on the back side. Alright. So we are going to use a cutting plier to remove the leads. What we are going to do is this: we are going to be as close as possible to the lead, and we are going to trim it off. Alright, these pieces are useful to use as jumpers later, so I would advise you to keep them safe for future use also. Right, so I'm just going to cut each of these at the point where the lead ends. Alright, it's easier to show poor soldering also. I'm just cutting these away. It's advisable to use the cutter to do the cutting, so because it's very precise, because you know exactly where it is going to cut. Alright, it's better to use this instead of a sleeve remover. So I'm just going to keep these away. Okay, this is the soldering. Alright, so the resistors have stayed in place and the soldering is complete here. There are a few types of poor soldering that I want to show you. One is where you have used excessive lead. Alright, so in those kinds of soldering, what happens is it will form like a crown. Alright, that's not good soldering. And in a good soldering, it will look like a tent. Alright, so So once you do the soldering, you could place this on the floor, on the table, and to remove the excess lead, you can do a touch. Alright, I'm pressing the PCB against the base and I'm just touching it once so that I can remove the excess lead that's on the pad. So you can see that when I'm doing that, the excessive lead sticks to the solder. The trick is to whip this soldering lead on some of the surface so that you can remove the excess lead on the tip itself. So when the tip melts it will absorb the excess lead, right? And then you just need to flick this in other places so that you can remove the excess lead. Do it with this. It's excessively hot. Make sure that you don't touch it with your hands. The tip is hot enough to melt lead, so it is going to burn your hand severely. So your excessive caution has to be exercised while you do the soldering. I have done some soldering. There is some poor soldering in some places left on purpose, so you could see it better also here. See, for example, this has excessive lead. This particular solder has got excessive lead. I just need to remove that. Alright. Okay. So that completes the soldering for the resistors. Alright.